Hello, everybody. My name is Graham Denning, and today we're going to be going over my Denning 45 Performance Sailing Catamaran as my final project for Yacht Design 2025. The contents of the presentation will start with the introduction as well as the use case for the boat, then we'll go into some defining characteristics and features of the boat, and then we'll talk about the design process and sort of a debrief and a conclusion. So I wanted to do a multi-hull. We hadn't done a catamaran this year, and I wanted the challenge. I wanted that design experience, as we've done a pretty good job getting everything else that seemed like the last thing to cap it off. And I've also done a little bit of cruising on a catamaran, and I really enjoyed that and wanted to do my own take on the sort of tropical weekend warrior boat. Some of the boats that I had on my parametric study were the Outrunner 45 and the Gunboat 48, which are both performance cruising catamarans, and that was the genre that I was going for. My use case was a sailing catamaran for extended island cruising or tropical day sailing that small families or two couples could sleep on comfortably for a couple days up to a week. And the ideal user is somebody that can appreciate the art and the sport of sailing without having to have every single creature comfort in the world. And some of the core characteristics that I wanted to keep central to the boat's design was a very performance-oriented hull and sail package, as well as appendages. A pretty basic system suite, not overly complicated, but enough to be a modern vessel. And then the ability to be shorthanded is also key. Moving into the hull development, the length of the boat, which I wanted to be around 45 feet, in the fineness ratio, which were the two driving characteristics. I decided on a 12-to-1 fineness ratio, as any higher than that, the performance you gain for the interior space that you lose does not make sense for a cruising boat. And this resulted in a hull that's 13.9 meters long with a waterline beam of 1.15 meters. And it's pretty narrow, but as you'll see later in the presentation, it works and it ends up with a pretty high performance uh, ceiling. For the sail plan, I wanted something large and easily managed for the shorthanding, but also for increased performance. And the key to this is the large mainsail, but also the self-tacking jib on the front, which allows for much easier shorthanded sailing as the jib tacks itself, which reduces the need to mess with jib sheets while you're trying to do 15 other things if you're sailing by yourself or with limited help. The next aspect are the dagger boards, and I chose dagger boards over mini keels as they have a much higher performance ceiling. And each dagger board is operated by lines that move it up and down depending on the current tack of the vessel, and they can also both be pulled up if you are motoring around in shallow water or if you're going to beach the catamaran in order to have a tropical picnic. Sort of a cool feature that's pretty limited to catamarans is the idea of a rotating mast. And the rotating mast has a wing shape in and of itself, and it offers a lot of benefits for catamarans that can't point necessarily as high as a monohull. It allows for a more optimized sail shape, allowing for much easier airflow. And like the dagger boards, it is also controlled by lines for the specific tack. For the engines, I picked two Beta 30 horsepower marine diesel engines, one mounted in each hull under the beds, typical shaft drive, accessed under the mattress, and they allow the boat to have a 350 nautical mile range under power, as well as increased maneuverability in marinas with the twin engine setup. For tanks and storage of fluids, we have dual 25-gallon tanks for the diesel, which is located on the back side of the bridge deck in a lazarette, and 150 gallons of fresh water located up front where you can fill it from the deck, which allows for a week or so depending on who's on board and how much water is getting used at any given day. For the structure of the boat, it's a wood epoxy vessel, and so the frames are 3/4 inch plywood with roughly 1.2 meter spacing, and the outside planking is calculated to be 5 millimeters all around the hull, and that was calculated with ISO. The interior of the boat, like I said, was designed to be able to sleep two couples or a family with a reasonable amount of kids. It has two queen-ish size beds with a private head in each hull, and there is the possibility to have a quarter berth ahead of where the dagger boards are stored in each of the hulls, um, which would be very cramped, but it could give you another space for the least favorite child. And so one of the interesting parts of catamarans was the specific calculations related to the crossbeam, which were done according to a paper by a guy named A.L. Dinsenbacher, who mapped out a way to calculate the loads under a variety of loading conditions that the boat faces using variables that end up being dimensions of your specific vessel, like waterline length and displacement and all that. And so you end up with these forces, and then the beam and the beam size can end up being calculated. This was by far the most challenging and difficult portion of the project as it relates to catamarans specifically. We also did some CFD runs, and the CFD runs for a catamaran are pretty cool because at the max riding moment, it starts lifting a hull out of the water, which gives a really cool visual, not only sort of in person, but also in the CFD software, where you can see it's flying that port side hull on the left image, and you can see on the right image the design pressures under the water on the dagger board and the rudder, as well as sort of on the bow. And the project evolved considerably over time. It was originally going to be a much stouter blue water cruiser, and as I developed and sort of settled into the design spiral, I wanted to narrow in the scope to being the tropical weekend warrior that I ended up with as my final project. Some future additions that I would like to have seen on the boat and could possibly work on in the future would be mapping out the electronics for a solar array on the hardtop, which would allow for you to operate all the systems on the boat without having to run your engines at all, which would be ideal. And moving around the tanks to lower the VCG would be nice, as well as doing a full FEA study using the beams that I calculated would be a really cool visual for the boat, and you can see how it'll perform. And so some things that went well and some things that went not so well. The whole design portion of the project definitely was the smoothest. And then some of the challenges were making efficient use of the space. I'm not particularly skilled at doing interiors, and the hulls and the bridge deck were very narrow and very shallow, and we got it in there, but it was a struggle for a little bit. And then I could have benefited from a little more time to sort of sit and marinate with the beam calculations, as it was a lot in a pretty short amount of time, but I'm happy with how it ended up. So in conclusion, designing a sailing catamaran from scratch is a real challenge. It was possibly a little biting off a little more than I could chew in the limited time that we had for the final project, but like I said, I'm happy with what I turned out with, and you can see this nice rendering of Denning 45, hull number 1, bending stress. A truly beautiful vessel. Thanks for watching the presentation. Have a great summer, everybody.